In this lesson, we'll take a look at hyperbolas, which are the fourth conic section that we are studying after circles, ellipses, and parabolas. The definition of the hyperbola is the collection of the points in the plane, the difference of whose distances from two fixed points called foci is a constant. If you recall, an ellipse is the collection of all points in the plane, the sum of whose distances from two fixed points is a constant. So this time we're taking the differences, and you're going to see that show up in the equation that I'll show you in a moment. A hyperbola has two branches, and you'll see them here. This is a left-right opening hyperbola with a left branch here and a right branch here. Okay, so you are going to have a center of the hyperbola. You'll have vertices along what is called the transverse axis. This is similar to the major axis of an ellipse, but the vocabulary is important that you make sure you understand transverse axis goes through the vertices, which is where the branches of the hyperbola intersect the transverse axis. Those points are called the vertices. There are also these foci that are effectively inside each branch, inside the curvature of each branch. The secondary axis here is called the conjugate axis. That's written right here, conjugate axis, and it's pointed to this axis here. So you have a transverse axis and a conjugate axis as opposed to a major and minor axis. You then also have co-vertices. And then you'll see this little square here that we create. We pretty much take the intersection points of the co-vertices with the conjugate axis and the vertices with the transverse axis, and we create this square. Then we draw diagonals through the square, and these are called the slant asymptotes, and they govern how wide or narrow each branch of the hyperbola is. So now let's kind of look at the equations that go with a hyperbola. This is a hyperbola with a horizontal transverse axis. And the reason we know that it's a horizontal transverse axis is because the x squared term is positive. Now remember I told you that a hyperbola is the definition of all points whose difference between two fixed points is constant. That difference shows up in the equation. If you have a positive variable squared and a negative variable squared, you're talking about a hyperbola. So in the positive, wherever the positive variable is, that will give you your transverse axis. Here, x is squared, so we have a horizontal transverse axis, which tells us that the hyperbola opens left to right. The center is hk, just like it has been in each vertex form for every parabola. The vertices are going to be the x value plus a and the x value minus a, and then the y value is stable. The co-vertices that do not touch the hyperbola, they go up, down, b from the k value of the vertex. The foci lie on the transverse axis, so when we have a horizontal transverse axis, we add and subtract the foci from the x value of the center. And then this relationship, c squared equals a squared plus b squared, is the relationship between a, b, and c for a hyperbola. Notice that you have addition here, which goes with the hyperbola being subtraction. With an ellipse, if you recall, with an ellipse you have x squared plus y squared, but then you have c squared equals a squared minus b squared. So you have an opposite situation happening when you're solving for c. Okay? The equations of the asymptotes of the hyperbola are always going to have the slope is going to always be b over a, because in a hyperbola, b is always underneath the y value, and a is always underneath the x value. So we really have just rise over run. And then we're always going to put our equations of our slant asymptotes in point-slope form. Do not multiply it out to slope-intercept form. If you're taking a look at a vertical transverse axis, here are the differences. Here your y value is squared and positive. That means the hyperbola opens up, down. The vertices will be up, down from the y value of the center. The co-vertices will be left, right from the x value of the center. The foci will lie on the transverse axis, so up, down from the y value of the center. The asymptotes follow the same exact equation of b over a as the slope, because b is always with let's see, this says A is always paired with the positive variable and B is always paired with the negative variable. If that is the case, then we don't always have B over A here. We always want basically the variable or the constant underneath Y divided by the constant underneath X for both of these. So let's move on to practice problems. Here we have a hyperbola. This says parabola, but it means to say hyperbola. Sorry about that. That opens left or right because our x squared is positive. So this is going to be left, right. And I'm going to go ahead and write down the center. That's easier for me because I don't have anything added or subtracted from x or y. I know the center is 0, 0. And that's easier for me to start with because it tells me my transverse axis is a left-right line, so y equals 0. And my conjugate axis is an up-down line, so x equals 0. And I know that these both have to go through the origin because my center is the origin. Okay, a squared is positive. A is always associated with the positive variable. So a squared is 16, a equals 4. B squared is always associated with the negative variable. So b squared is 4 and b is 2. C squared always equals, in a hyperbola, a squared plus b squared. So c is the square root of 20, which I'll write as 2 rad 5. The vertices are going to go left, right from the center, and they go left, right by a. So I'll have negative 4, 0, and I'll have 4, 0. The co-vertices are going to go up, down from the center by the b value. So 0, 2, 0, negative 2. The foci are also going to go left, right from the center, and they're going to go left and right by c. So negative 2 rad 5, 0, and 2 rad 5, 0. And then the equations of the slant asymptotes, I'm actually going to go ahead and graph this so that you can see how I find this. But if I have a center here at 0, 0, I go left by 4 and right by 4 for my vertices. I go up by 2 and down by 2 for my co-vertices. And then I'm going to draw this rectangle here that kind of connects my vertices and co-vertices. Okay? Next thing I'm going to do is draw equations for the slant asymptotes, or draw the lines for the slant asymptotes. And they need to go through the corners of my rectangle, like that. So you see that my intersection points are here, and then here, and here for drawing diagonals of a rectangle. Well, that helps me in order to draw how wide my hyperbola goes. So I start at a vertex and I go close to the slant asymptotes, like that and like that. And I do need to draw in the foci. The foci, remember that rad 5 is slightly over 2, so 2 times slightly over 2 is just over 4. So my foci come out here to just over 4 and just over 4 each on the positive and negative side. And then all I have to do is figure out the equations of these slant asymptotes. And my slope is going to be rise over run. So you want the square root of the value under y, so the square root of 4, over the square root of the value under x, so the square root of 16. So I should have 2 over 4, or 1/2. And that makes sense because I go up 2 and right 4. So normally I would write the equations of my slant asymptotes in point slope form. But since my center here is 0, I think it's fine just to write y equals plus or minus 1/2 x. Okay, let's try another one. We are now given a hyperbola that is going to be oriented up-down because the y squared term is positive. So this is up-down, and that should once again say hyperbola there. I do have a center that is not the origin, so I'm going to write the center in first, negative 2, 1. And I'll plot that here. And then I'm going to go up and down by 5 to get to the vertices. So I'm going to go up 2, 3, 4, 5, and down by 2, 3, 4, 5. So that gives me my vertices of negative 2, 6, and negative 2, negative 4. Sorry, I wrote that in wrong. Okay. My a value, a always goes with the positive term, so the square root of 25 is 5. My b value always goes with the negative term, so the square root of 9 is 3. That also helps me put my co-vertices in, right by 3 and left by 3 from my center. So that'll be negative 5, 1, that's a 5 right there, and 1, 1. I think it's time to go back and write my transverse axis. That is going to be a vertical line, x equals negative 2. The conjugate axis will be the horizontal line, y equals 1. My c value I get from c squared equals a squared plus b squared. So c is going to be the square root of 34, which I know to be almost, almost 6. I was about to put in plus or minus there that I don't need. Sorry about that. Almost plus or minus 6. So I could go up by almost 6 from the center and down by almost 6 from the center. Now I'm going to go ahead and draw my rectangular shape that connects my vertices and co-vertices. And then I'm going to go ahead and put in my slant asymptotes. There's one of them. There's the other one. This tells me how wide my parabola opens, or my hyperbola opens. I go out and I hug my asymptotes there and there. And then all I have left to do is write the equations of my, I have to write my foci first, sorry. I start at my center, so negative 2 is the x value of my center, and then I'm going to have my y value of my center plus c, and then I'll have negative 2 and my y value of my center minus c, which of course is that square root of 34. And now the last thing I need to do is write the equation of my asymptotes. This is a perfect case where you want to keep it in point slope form. So you're going to have y minus the y value of your center equals, then you need the slope, which is rise over run. You went up 5 and right 3. Remember, it's basically the square root of the number under y, because y is always my rise, so that's 5, and then the square root of the number under my x, which is always my run. So 5/3 is my slope, and I'll come down here, and I'll put in 5/3. I need plus or minus 5/3 to get the two different lines, one with positive slope, one with negative slope, and then I need x minus a negative 2 as my x value of my center. I would leave it in this form. Do not multiply it out.